All right, we didn't have time to go over this in class this week, but I'm going to make sure that you have it for your studying purposes. This is the study guide for the chapter 4 exam that we would have had. Which arrangement correctly show the results for the vector a plus b, which is r? So you remember the rules. We have to add them and draw them. Whoops, wrong term. We have to draw them tip to tail, right? So this is not drawn tip to tail. This is not drawn tip to tail. This is drawn tip to tail, but R was drawn incorrectly. And so the answer is A. I have drawn tip to tail, and then I have drawn R from the beginning to the end. Okay. A vector shown below has a magnitude of 10 meters and a direction of 30 degrees above the x-axis. Answer the three questions. What is the y component, which is the vertical component of the vector? So that means the vertical component. And what is the x component, which is the horizontal component? So I can find my y, which is equal to the hypotenuse times the sine of 30 degrees using my SOHCAHTOA relationships. And I can find my x, which is equal to the hypotenuse times the cosine of 30 degrees. So I would have to use my SOHCAHTOA equations to find the x and y component of the angle. And so that would be 10 times sine of 30, 5 meters. And the x component would be 10 times cosine of 30, and that would be 8.7 meters. Okay. Please double check your calculators in the correct mode by plugging those in. And if you don't get the answer that I just got, then that would mean that you have it in radians. What is the direction of the vector shown? 30 degrees above the positive x-axis. Or you could say 30 degrees north of east. A vector A has a component of -3 and -4. X component, what is that one? That is the horizontal. Y component is the vertical. So we need to sketch the vector. They gave me the components. I have to sketch the vector. So I would have to go to the left 3, down 4. That's the components. What is the vector? Starts at the beginning, goes to the final location. This is the answer. This is the vector A that they described. What is the magnitude of A? Well, A squared has to equal 4 squared plus 3 squared. And we would have to take the square root of both sides, right, to get A by itself. So A is equal to the square root of 4 squared is 16 plus 9 is 25, which equals 5 meters. What is the direction of the vector with respect to the x-axis, negative x-axis? So let's imagine, here's my axis, x and y. And we had to draw that vector by going off to the left 3, down 4, and then this is what the vector looked like. That was the vector A, we called it. And we found it to be 5 meters, and we wanted to know the direction, so we got to have the angle. How would I find that angle? Well, I can use the fact that I know the opposite side and the adjacent side. So the tangent of theta is equal to opposite over adjacent. I got to get theta by itself. So I'm going to take the inverse of both sides, inverse tangent. Opposite side was 4, adjacent side was 3, so theta is equal to 53 degrees below the negative x-axis. Which vectors in the sketch below are equal? Well, a vector has to have the same magnitude and direction. This is the only two that have the same magnitude and direction, so A and C. What needs to be the same for the two vectors to be equal? Select 2, magnitude and direction. Can have any ending point or any starting point as long as the magnitude and direction are equal. Student walks 3 meters north, then 2 meters east. Sketch the path and draw the resultant displacement vector. So it goes 3 meters north, 2 meters east. Sketch the path, which I did, and the resultant vector. Start at the beginning, go to the end. Calculate the magnitude. So I'll call that A equals question mark. So A squared equals 3 squared plus 2 squared. So A equals the square root of 9 plus 4. And you can plug that in to your calculator. So the square root of 13 is 3.6 units of meters. So that is its displacement in 2 dimensions. It also asks for the direction, okay? So how do I do that? Well, let's imagine this on an XY plane. This is my X, this is my Y. So let's draw that on an XY plane. So I went up 3, to the right 2, and then I have a direction like that, and we found this to be 3.6. Now we need to know an angle. We've got to have an angle. So I will find, since I have this triangle inside, I'll find this angle right here. So we'll call that theta. So theta equals the inverse tangent of the opposite side, which is 2, over the adjacent side, which is 3. So theta equals 2 divided by 3, 33.4 degrees. So this is equal to 33.4 degrees. Now we got to describe that. You can describe it more than one way. So that is 33 degrees to the right of the positive y-axis. You could also tell me this angle, which would be 90 minus 33.4. So that angle is 56 degrees. 0.3 degrees. So that would be another way to say it is 56.3 degrees above the positive x-axis. Okay, the velocity of an object is 30 meters per second, 50 degrees above the positive x-axis. So here's my x-axis, here's my y. I know that I am above it at 50 degrees, and I have 30 meters per second. What is the velocity in the x and y direction? So what are they asking for? They're asking for this side of the triangle, and they're asking for this side of the triangle. So let's just look at the angle itself, or the vector itself. So I have 30 meters per second, and I want to know this x side and this y side. So x and y. All right, so how do I find the x velocity and the y velocity? Well, the y velocity is the opposite side, so that is 90 notice I'm the opposite side of 50 degrees, so I use the hypotenuse times the sine of 50 degrees. And the x side is the adjacent, so I take the hypotenuse times the adjacent side of 50 degrees, and I can plug those into my calculator, and I get 30 times sine of 50 equals 22.98. I'll call that 23 meters per second. And then 30 times cosine of 50 degrees gives me 19.28. I'll just call that 19 meters per second. And there is my velocities in the X and Y direction. A rock is thrown horizontally off a cliff with a velocity of 11 meters per second. The cliff is 50 feet above the water. How long does it take to hit the water? So I've got to have my X and Y chart. So my Y initial equals 0. Acceleration in the Y direction is negative 9.8 meters per second squared. And we know delta Y equals negative 50 meters because it fell 50 meters. Velocity initial in the X direction is 11 meters per second. And we also know the acceleration in the X direction is 0. There's only one equation that works in the X direction. Well, change in displacement in X is equal to its velocity in X times time. I left off the subscript initial because the velocity in the X direction never changes. So if I want to know time, I have to use something in the Y direction to find it. Okay, because the equation in the Y direction right here, I could use that to find time, but I only know the initial velocity in the X direction. I don't know how far it went in the X direction, so it's not going to help me. There's only one equation that will work, which is change in Y equals velocity initial in the Y times time plus 1/2 acceleration in the Y times t squared. Since velocity initial in the Y is 0, that part of the equation drops out. And we know that delta Y equals 1/2 a in the Y t squared. We're going to rearrange all that algebraically. We're going to multiply both sides by 2 to get rid of the half. We're going to divide by AY to get rid of the AY. And then we're going to take the square root of both sides of it. And all of that will result in T equals 2 times delta Y over A to the Y and the square root. And if we plug in all our values, we find T to be equal to 2 times negative 50 divided by negative 9.8. Negatives cancel, take the square root of all that, and I get 3.19 seconds. So that's how much time it takes for it to hit the water. Now I can come back over here and put time in both the X and the Y, because time is doesn't have a dimension or direction. It goes to both sides, right? 3.19. How far? So how far? What does it mean? They want to know delta X. So now I have to use this equation. So B delta X equals the initial velocity, which is 11 meters per second, times that time, which is 3.19, and we get delta X to be equal to I get about 35 meters. Okay. A golf ball is struck such that it leaves the ground at 25 meters per second. So here it is. It has a velocity of 25 meters per second at an angle of 25 degrees above the ground. Then we have to have our X and Y. And we're gonna have to define where's our, I'm gonna say finalist at the top. And I'm gonna say initial is at the bottom. So this is, chart is from to the top, because we can make another chart from the initial to the final location at the end of the path. But anyway, here's my X and my Y. I know velocity in the initial X direction equals something, velocity in the Y direction equals something. Now I actually have to take that vector, 25, and break it up into its X and Y components, which is equal to 25 times the sine of this angle, which was 25 degrees. So 25 times sine of 25 equals 10.6 meters per second. And then in the X direction, it's hypotenuse times cosine of 25 degrees. And that will give me 22.7 meters per second. Now I can fill this in, 22.7 meters per second and 10.6 meters per second. What else do we know in the Y? Negative 9.8 meters per second squared. And in the X direction, I don't know anything else other than acceleration in the X direction is 0. And the only equation that works in the X direction is Vx times time, because the velocity in the X direction never changes. Now we know something else on the Y direction, because at the very top, what do we know? We know the velocity there in the X direction is equal to 25. I'm sorry, not 25. 22.7 never changes. And we also know the velocity at the very top in the Y direction is 0. So we know Vy, we'll call that final, because that's what we're going to define that as our final location for this part. We want to know delta Y equals question mark. Okay. So that was B. So how do I find delta Y? V final squared equals V initial squared, this is B, plus 2A in the Y. These are all in the Y, delta Y. What was, so I can't get rid of, I can't, yeah, okay. I have an initial velocity in the Y direction. I have nothing in the Y at the final location, it's 0. But so we know this is going to, that final velocity is going to cancel. But let's solve for V or delta Y. And I am going to go backwards on PEMDAS. So some people struggle with how to do this. So we know that when we're doing math problems and we're trying to solve them, we have to do parentheses, exponents, math, multiplication, division, addition, subtraction last. But when you're trying to isolate something like what we're doing, we got to go backwards. So is there a term on the side where Y is that I have added or subtracted? And then we got to get rid of it. And the answer is yes. We have B initial squared that has been added. So I have to do the opposite. So I have to subtract it. So we're kind of going backwards on PEMDAS. And so I subtract it from both sides. So V final in the Y direction squared minus V initial in the Y direction squared equals 2A Y delta Y. I'm trying to get delta Y by itself. Now, look at PEMDAS is there. I took care of my addition and subtraction. Is there anything that was multiplied or divided by on delta Y? And the answer is yes. Well, how do I get rid of it? I do the opposite. So because 2 was multiplied and AY was multiplied, so I've got to do the opposite. So I'm going to divide. And I have to divide both sides, the entire sides by that. And now I get delta Y by itself. So I get B final squared in the Y direction minus V initial squared in the Y direction divided by 2 times acceleration in the Y direction equals delta Y. Now I plug in all my values. And so I'll do that over here. Delta Y equals, what's the initial or final velocity? It's 0 minus, what's the initial velocity? 10.6. I'll square it and I divide by 2 times the acceleration. And I will find the maximum height to be 10.6. Come on. squared divided by 2 divided by 9.8. Negatives will cancel. 5.7 meters. So that is the maximum height. Oops, I reversed those. 5.7 meters. What's the total time in flight? Well, I'm going to use my y dimension. So this is d. I'm going to use my favorite equation. So I got to get time by itself. I got to go backwards in PEMDAS, or have anything added or subtracted on the side where t is. I do. So I've got to do the opposite of whatever that is. So v final minus v initial equals a times t. Now I'm doing anything that's multiplied or divided by and doing the opposite. So a was multiplied, so I'm going to do the opposite, which is divide. And then I get t equals v final minus v initial over a, and then I can solve for t because I know all these things. So the time to get to the top is what v final minus v initial divided by acceleration in the y direction, and time equals 1 point, we'll call it 1.1 seconds. That's to the top. Okay. That's to the top. How about the total time? That's actually what it asked for. Well, I got to multiply that times 2, which equals 2.2 seconds. Okay, E. How far in the x direction will it travel? Well, there's only one equation in the x direction. And now I can use delta x is equal to the initial velocity in the x direction. I dropped my initial because it never changes. So what is that number? 22.7 meters per second. And now I need the time, total time that's in flight, 2.2 seconds. And I get 49.94. You can call it 49.9 meters. And that is E, this is D, this is C. Oh, no, that's not C. This is C. I got lost in my problem here. This is B. We found both of those here. And this is A. Okay. I hope that helps.